Let us see how we can solve the same number 6b using method 2. I said in the previous video that method 2 is Pascal's triangle, and in some books you'll find that it is called addition triangle. So in case it comes in your exam that expand using addition triangle, please, it is the same as Pascal's triangle. And before I go into the question, I believe you have a background of the Pascal's triangle, and the Pascal's triangle is in this format. Its main aim is to give us the coefficients that we need to use in our expansion. So the format is, I will have here coefficients, I'll put here coefficients, and then the coefficients correspond to powers, and the powers as well correspond to the coefficients. If the power is 0, the coefficient is 1, and you know that any number to power 0 is 1. That is the same concept employed here. Any number to power 0 is 1. So if the power is 0, then we have a single coefficient 1. And how do we get the rest of the coefficients? Like for example, if the power is 1, if the power is 2, 3, and 4, it goes on. So if the power is 1, now the coefficients, when we are employing Pascal's triangle, we say, after writing 1 here, for the power of 0, the next coefficients will be, just write 1 and 1 on the sides. Don't write anything directly on 1, which is directly under 1. So we write here and here. That is, these are the coefficients when the power is 1. Coefficient will be 1 and 1. What if the power is 2? What are the coefficients? We simply add. To write a coefficient, I will say 1 plus 1 is 2. So we write 2 here. And then again we put 1 on the opposite side. We guard it with 1s. 1 here and 1 there. So if the power is 2, the coefficients that we can derive from Pascal's triangle are 1 to 1, corresponding to the terms. This means that our answer, if the power is 0, we shall have 1 term. If the power is 1, we shall have 2 terms. If the power is 2, we shall have 3 terms. What if the power is 3? We add 1 plus 2, 3. 2 plus 1, 3. And then again we guard it with 1 and 1. So if the power is 3, coefficients from Pascal's triangle are 1, 3, 3, 1. And they are 4. That means we shall have 4 terms. And if you look at our question, we have a power of 3. So someone could just stop here, because this is what the question wants. But for your purposes of understanding, let me add if the power is 4. If the power is 4, the coefficients become 1 plus 3, 4. 3 plus 3, 6. 3 plus 1, 4. Then again we put 1 on the opposite sides. So if the power is 4, we shall have 5 terms. And these are the coefficients. 1, 4, 6, 4, 1. And it continues. Okay, if the power is 5, we simply say 1 plus 4, 5. 1 plus 4 is 5. 4 plus 6 is 10. 6 plus 4 is 10. 4 plus 1 is 5. And then you put 1 and 1 at the end. So if the power is 5, there are 6 coefficients on that number. But without wasting time, we have seen clearly that our power n, these powers are the n. Our power n is 3. So we shall stop here. And these are the coefficients that we are going to use later. So we have seen how to deduce the coefficients based on the power. If the power was 4, then we will take the coefficients corresponding to corresponding to 4 and even 5 depending. So we have got the coefficients. Now after getting the coefficients, how do we now integrate the coefficients to assist us in expanding that number? So you copy the number equals to, this is the number. Let me close out the coefficients for now, leaving that part. Remember, any expansion is in the form of a plus b to power n. And in this case, a is the first term, and if we are to compare, our a corresponds to 2x, our b corresponds to 1, and our n corresponds to 3. And the general expansion in the form of a plus b to power n with Pascal, we have said that in your previous learning that the powers of the first term, which is a, the powers of the first term a will start from n. So here we shall have a to power n. And the powers of the second term b will start from 0. So we shall have b to power 0. Now, the powers of a are going to decrease from n up to 0. The powers of a will decrease, powers of a, they will decrease from n to 0. But the powers of b will increase, they will increase from 0 to n. These are the powers of b. So now from here, our a to power n, now it means in the next term, the powers of a will decrease by 1. So we shall have a to power n minus 1, but the powers of b will increase by 1, giving us 0 plus 1. And the third term, the powers of a will again fall by 1. So we shall have a to power n minus 1 minus 1, that gives us minus 2. Then for b will increase to, they will increase to 2. And the next term again, the powers of a are again going to fall by 1. So we shall have n minus 3. Then the powers of b will increase to 3. And this continues depending on the value of n until the power of a is 0 and the power of b now has increased to n. So the powers of a fall from n to 0, but the powers of b rise from 0 up to n. They are opposite. And now to integrate this, I've taken time on that, but I believe you have a background of that. Now to integrate that, I will now have 2x plus 1 power 3 equals to, we just follow this just to guide us. What is our a? Our a corresponds to 2x. So here we shall have 2x plus 1. Oh, sorry. Our a is 2x. So we shall have 2x to power n. Our n is 3. And then our b is 1 to power 0 plus. Again, our a is 2x power n minus 1. N is 3. 3 minus 1 gives us 2. And then our b, which is 1, rises to a power of 1. And then plus. Our 2x again falls by 1, because here we shall say n minus 2. That is 3 minus 2 to gives us 1. Our b, which is 1, increases by 1. Its power increases by 1 to form 2. Plus our a again decreases by 1. 2x, which is n minus 3. N is 3. 3 minus 3 is 0. And then b, which is 1, its power rises to 3. So this is the general format of the expansion. Now remember our n was 3. And if n is 3, we shall insert these coefficients 1, 3, 3, 3 in that order and they correspond to the terms. That means here we shall have a coefficient of 1, and here we shall have a coefficient of 3, here we shall have a coefficient of 3, and then lastly we have a coefficient of 1. That is how we employ the coefficients from the Pascal's triangle. So from here, I have inserted the coefficients and I've followed the rule of expansion, where the powers of A decrease from n to 0, but the powers of B increase from 0 to n. Now let me cover that, and then we simply simplify this. What is 2x power 3? That is 8x cubed. 2 power 3 is 8, x power 3 is x cubed. Then time is 1, you still have 8x cubed. 1 to the power 0 is 1. 1 times 8 is still 8. It makes no difference. Also here, 1 to the power 1 is 1. And if we multiply 1 by this, it makes no difference. So what is 2x power 2? That is 4x squared. 4x squared times 3, it gives us 12x squared. And then here we have 1 power 2, which is still 1. So this makes no change to our expression. 2x to the power 1 is 2x. 2x times 3, it is 6x. So here we shall have plus 6x. And then 2x to the power 0 is 1. 1 to the power 3 is 1. So 1 times 1 times 1 is still 1. So here we shall have plus 1. Plus 1. And this is the answer when we are using Pascal's triangle to expand that given question. And if you go back and review or look at the answer that we got in method 1, it is the same answer. That means that the two methods, or all the methods, give the same answer, just that we have different ways of applying each method. So this is the answer. If you have a knowledge of the method we are going to, you can try it out, and then we confirm in the next video. This is Vision Plus, and thank you for being part of the chosen people to get these resources.